Hello everybody, it's Mike here at Game from Scratch. Welcome back to our ongoing Godot 3 tutorial series. Today we're going to start getting into a bit of the fun stuff. Specifically, we're going to talk about 2D graphics, sprites, atlases, and animation. So quite a bit to cover, but hopefully it won't be too long of a chapter. Speaking of chapters, there is also a work in progress, or finished, I guess, depending on when you're watching this video, a book that I'm developing on the exact same material. If you are a patron backer right now, this chapter is up and live. There is also a chapter on GDScript programming and a video on GDScript programming coming very, very soon. So if you find the coding in this a little daunting, don't worry, there will be a video up any second now for GDScript development, so that should actually get you up to speed on that topic. One other thing to talk about before I move on too far is notifications. I mean, if you've been watching a lot of YouTube videos, you've probably been getting the same speech over and over again, but apparently Google changed the algorithm behind the notification process, and if you have not clicked that little bell icon, apparently notifications doesn't mean what you think it does. So if you can't just be subscribed to a station, you have to be also subscribed for notifications to actually be guaranteed to be notified when a new update comes. So if you want to be updated right away when I release a new chapter, unfortunately you gotta go click that little bell as well. Knowing it'll change, sorry to waste your time on that, but sadly that's the state of things. Alright, so anyways, back to the tutorial series. We are going to start things off with some sprite drawing. Now if you've never heard of it, a sprite is basically a terminology for a piece of graphics that move. It actually started way back in the day. Texas Instruments made a chip that handled sprites, and this used to be the bragging point for consoles and 8-bit computers. Basically, they used to brag about how many sprites they could handle in hardware. And so back then, it used to be a thing. Now, basically, a sprite just means a graphic that moves. So pretty much, you've got a texture or part of a texture, and you've got some coordinate information. You put those together, and you have a sprite. And that's what we're going to talk about initially today. But in order to pull that trick off, we're going to need some graphics. And so that we can all work from the same page, I sourced some great free graphics from the internet. Specifically, I am using this knight character free sprite, available at gameart2d.com. I will link this down below. So you can obviously swap in whatever you want to use, but this is where I'm getting the graphics from. Specifically, we are using this guy right here, as well as this guy, which basically I took one of the walk animations from the cycle and I smashed it all together using Texture Packer. This is something called a Sprite Atlas or a TextureAtlas we'll use in this example. And then I also have a folder of frames like so that we are going, oops, I'm in the wrong folder. Where did it go? Oh, anim. There we go. A folder of frames like this that we're also going to use in this particular animation. So without further ado, let's jump in. If you want to follow along directly, do go to that link. Like I said, it will be down in the comments below. Head on back over to the Godot engine. I've already got things set up. So basically, I created a world root. I saved our scene. I set our scene as our run scene, and we are ready to go. Now, if you don't know how to do all of that, do be sure to check the earlier part of the tutorial. I've walked through all of this stuff, and each of these tutorials builds off the previous tutorials. So I've done the stuff we've already covered. Now it's time to jump into the 2D world. To do so, just head on up over here. Make sure you are in 2D mode like that. Now, this little toolbar up here is also, you can switch between these tabs quite easily using the hotkeys. So you can also go to, by hitting the F2 key, you'll switch to 3D, F1 back to 2D, and F3 brings up help. Not what you'd expect, but, so F1, oops, I'm missing. So, no, F3, script, 2, 3D, F1, 2D, F4, help. So asset lib isn't what you would naturally expect, but these three right here, you can switch between using the F keys. Now, once you're actually in this is where your 2D editor comes in. You'll notice something right off the hop. You've got a couple of lines going on here. So you've got this green line, that's your y-axis. This red line represents your x-axis. So you'll notice here we're below on the x-axis. And you've got this viewport here. Well, that's actually a really important thing being shown. This is where your graphics are ultimately going to be drawn. This is the visible or viewable area. We're not using a camera or anything in the scene. So how does it know how to design that or to draw that? Well, when you create a Godot scene, there's actually a root above your entire scene hierarchy called root. You'll notice it earlier when we did the nodes tutorial that we did this get root. Well, root is actually a viewport class. So we bring in here to the scripts. I'll show you quick. Oops, wrong one. Classes viewport. So your root is one of these. This is the top level character that holds all of your 2D game. So just to be aware that it's basically creating you a viewport into your world. Now, how actually does it get its values? Well, that by default, well, you can set it with code. We're not going to do that in this particular case, but instead what you probably want to do is go into your project settings, like so, and locate display right here, window. So there is your viewport settings right there. So by default, it is 1024 by 600. You can resize it. It's got a border, it's not full screen, etc. But if you want to switch those things out, if you're on a high definition or high DPI display like an Apple Retina display or HDPI on Windows, etc., you can support it there. And you can also tell it how it's going to handle various different aspect ratios. We'll touch on this later on when we get into viewports and cameras, etc. But this will basically enable it to scale down to devices that don't actually support this resolution. This is a virtualized resolution, and this is how you deal with, so if you're on like a Samsung, for example, that might be 16 by 10, and your resolution is 4 by 3, this tells it how to scale between the two things. So this is where you do your settings. Once again, that was in your project settings, display window. And that will also, if you change that value, this little viewport here or size will update to show your new correspondingly sized viewport. So again, quickly to summarize, there is a top level node called root that is ultimately a viewport that is created for you automatically. Pretty powerful stuff actually, and it makes 2D a lot easier to work with. Now in the editor here, you may notice I've been moving around at whim. Well, you can do that with the scroll wheel. Zooms in and out. You also can go here back to 1 to 1. You can plus, you can minus, like so. You can pan around. I don't know why pan's not working for me all of a sudden. There we go. Once you're zoomed in enough, you can pan around using the middle mouse button or by going into pan mode and then the left mouse button. Let's go back to the edit mode here. So you've got your different selection modes here. You've basically got select mode, move mode, and rotate mode. Those are also controlled by a series of hotkeys. So you can come up here and deal with them that way. Or you can use Q, W, and E to switch between them. That QWE is from the Maya 3D package. It's very common hotkeys for switching between selection, moving, and scaling, or rotating in this particular case. So this is your level. At the same time, you've got the ability to turn a grid on and off, like so, and you can snap to that grid. We won't cover that specifically. So that's a quick crash course on the 2D editor. Now let's actually jump into dealing with sprites. Well, first things first, we're going to need some graphics to actually work with. So I'm going to just go ahead, drop to my desktop. We'll grab this night sprite, and we drop it here. And you'll see it was just automatically imported. When you go up here to the import, you can see the settings that it was imported as, like so. We don't need to change any of the default settings for now, but that is, if you need to change them, you can change them up there and click re-import. Another way you can bring files into here is simply by right-clicking it and showing it in File Manager. And you'll notice here, it is simply a file system. And we're actually going to bring in the other files at the same time. So we're going to want to bring in that sheet and then this folder full of animations. So I'm going to show you the other way of bringing things in. I just dragged and dropped them over. So now we head on back over to the Godot, and you'll see it is now importing all of those various different assets for us. So there's two approaches. You can basically drop them directly into the file system for your project, or you can drag and drop them onto this window over here. You'll notice that the animations came in as their own folder. You can also arrange things in your own folders here using new folder. Okay, so now we have our sprite graphic to work with. Now let's go ahead and create a sprite. With our root node selected, create a new node. And the node type we want to create is predictably enough a sprite. Now a few things to notice here. Sprite is inherited from Node 2D. That means it gets all of the functionality that Node 2D did, as well as canvas item and node. So for example, Node 2D or canvas item, one of those two has all the positioning information. So that's where it gets its particular information from. And I'll show you exactly what I mean in a second once we've created one. So I created a sprite right here. We'll call him my sprite. And you'll notice down here in the inspector, it's got these various different categories. So you see sprite is the top level. This is the node type that we actually created. But as I said, it inherited from Node 2D, canvas item, and node. And you notice as a result, it gets all these various different properties from each one of those sub-node types that it inherited from. It's a very important concept of how nodes work in Godot. I'm not going to get back into it. We covered that in the previous section. So let's move on. So now that we've got our sprite, now we need to go ahead and apply a texture to it. This can be done in two ways. We can go click and load, or click and new, and then pick the type and then select it. Or we can literally drag and drop to the category that we want. So there we go. We now have a sprite. As you can see, it is positioned in the world. We can switch into the move mode to move it around, like so. Now you'll notice right off the hop, it is kind of big. In fact, it's off of our viewport for size. So we can scale that down. That is what, where's scale mode on? Oh, it's in select. And grab it by one of these corners, and you can drag it down and scale it to fit that way. Or we could also rotate it like so. And I'm going to undo that because I don't wish to rotate it at this point in time. But that is it. That is creating a sprite. It is really, honestly, that simple to deal with sprites in this game. And basically, if you're creating a 2D game, sprites are going to basically be the backbone of that game. Now, one thing to be aware of, back to the import process. So if I go to this knight here, now a lot of times some people are working with 8-bit style sprites. So one of the things that happened with this import is it's actually being filtered, which is to say it's being smoothed, shown nicely, kind of like anti-aliasing. But if you're going for that chunky 8-bit look, one setting to be very aware of is you probably want to turn filtering off and then do a re-import. And that will give you your original pixels, pixel for pixel, exactly how you meant it to be. So one of the most common changes when dealing with 2D graphics is this filtering right here. All right, so without further ado, let's head on back over to our scene. Let's head back to the scene mode, and I want to show you a couple of other things here that are very important. Now, first off, you'll notice that as I move this sprite around, I'm still in rotate mode. All right, so W, as I move this sprite around, its position over here is being moved. So transform. So here is position. Let me just expand that out a bit so you can see. So here you can see we're at 111 and 171. So let me move this guy around. You'll see now we're at 498 and 359. Well, what exactly is that coming from? Well, that is relative to the top left-hand corner. So there, right there, that's called the origin. So that's where X and Y are at 0. And then we're moving relative to it. Now, what you'll notice here is, in this case, though, we're actually moving relative to the middle, not to the top left. So you see, if you look really closely, there's that little plus mark right there. That is the pivot point, or the offset. So right here, if you want to move the offset around, you can, but what you often end up doing is you're either going to do it via the center, which is the default, like you're seeing here. So this position is relative to the center of our sprite, or we can set centered off, and then suddenly it's to the top left. So you see here our coordinates 245 and 281. That's 245 here, and 281 this way. So you notice if I bring this guy back to 0, 0, you'll see it, well, close to 0, 0. That makes the coordinate system according to the top left corner. So the top left and the center are the two most common coordinate system. Now, doing it centered has an advantage if you're doing rotation, because rotations happen relative to the pivot point as well. So you notice if I rotate this guy, it's rotating around that pivot. Now, what you actually want to do is really up to your game, but do be aware the centered is where that is controlled from. So you notice 0, 0 all of a sudden goes snap right back to the middle. Which one you want to go with is ultimately up to you. Just be aware that both actually exist. So now that we know our way around the 2D editor and we know how to create a sprite, let's look at a little bit of the scripting involved. So let's just go ahead and attach a script to this guy. So, and again, I have a tutorial coming or already out, or I don't know how timeline's going to work for you, but there is a GD script tutorial that should be released alongside this one that will explain this entire process. So I'm not going to go into a whole lot of detail. So let's go ahead and create a script. Zoom that down a little bit. Let's bring our guy back over here a little bit. And we want to keep all that. Let's get rid of these comments. They're not needed. We know what we're doing here. All right, so now this is a script attached to our sprite that is going to control what it does. So in our ready function, this is the function that's called when, well, it's ready, when it has, it's ready to be used in the game. Let's show a couple of things that can be done. Now, one of the things that we've got with our sprite is an attribute called position. Now, you'll notice earlier on I was in here. Anytime you want to know what a class can do, just search for it right there. So for example, here you can see all of the various different functionality in Sprite. Now, do keep in mind, however, that that Sprite also gets all the functionality from the classes above it. So for example, Node2D, it's got all these properties, etc. So you can see here, it's got a vector2 called position. Well, that's what we're about to play with in our code. So let's head on back over to our newly created script. So position, and we're going to set it, as I mentioned, it was a vector2, so vector2, and I'm just going to show you how to basically center something to the screen. Now remember there was that root node of type viewport. Well, we can automatically get a hold of that guy using the code called get viewport, like so, and we'll get size.x, which basically will give us our window's width, and get viewport size.y, div2. All right. So basically what this code will do, if we go back over here, you will see we are in the top right-hand corner. We run our code. And poof, we're immediately centered to the screen. So that's exactly what that code did right there. So basically it shows how to set the position of a sprite, or a node 2D actually, and it shows you how to get the graphics, how to get the screen's dimensions, etc. So you can position things relative. Now do keep in mind, we have the origin set at centered. So that, or the offset is set to centered. That is why we were ultimately centered in the screen. Otherwise, we would have been drawn relative to the top left corner of our sprite. All right, so that is moving. Well, let's show a couple other things. How do we scale? Well, that's just as easy. Scale, vector 2, 30, 30. So what we're doing basically is scaling our x coordinate and our y coordinate down to 30% of what they currently are. We go ahead and run that, and boom, we are now much smaller. So scaling is exceedingly easy when it comes to code. And next up we come up to rotation. Now rotation is also just as easy. There is a method called rotate, and you pass in the amount to rotate by. Now by default it uses radians. Radians are intuitive to certain people. I am not one of said people, so I'm going to use a little helper function called degrees to radians, or deg to rad. What this does is converts the degrees value, which is probably what you think in, to radians value, like so. So basically that turns 90 degrees into point whatever radians, and then that passes the right value into the function. But you will now notice we run our code, we are positioned, we are scaled, and now we are rotated 90 degrees. You could have also passed in a negative and rotated it in the opposite direction, or I guess I could have passed in 270 and ended up with the same result. So that really is the process of animating this guy. Now the last thing I'm gonna do is, we're gonna do on a frame by frame update. So set process equals true. And now let's implement the process function. I'm going to show you a couple of things here. So first things first, we're going to, each frame we're going to do a little bit of rotation. Same process, rotation equals self.rotation plus deg to rad 90 times delta. Now I'll come back and explain exactly why I did that in 1 second. It's a very important concept. All right, so what this should do is now every frame process is going to be called, and we're going to rotate by a little bit. So now you see we are now spinning. So pretty cool, pretty straightforward. Now, why did I do this? This is, delta is a value passed into process, which basically says how long since the last time process was called. So if, for example, and I'll do the math in front of you, if, for example, your game is running at 60 frames per second, that means each frame takes 0.016666 of a second to run. And that will be the value passed in as delta. Well, the cool thing about this is also the fraction of a second that each frame takes. So this is saying this value, this is 0.166, is saying that this is 1/60th of a second. So if you want to normalize your speed or your coordinates to run at a certain rate, so in this case, I want to rotate at 90 degrees per second, all you have to do is multiply it by that delta, and basically it will figure out what fraction of a second each call through update is going to, or each call through process is going to take, and move by that small fractional amount. By normalizing and using delta, what's cool with this system is if your machine is running at 60 frames per second, that value will come back at 0.133, and it will update, so that when a second has elapsed, it will have rotated by a second. But if your machine is running at 15 frames per second, that value will instead be, shouldn't have gotten rid of this guy, 0.6, which is obviously going to be like a fifth the speed. So you're going to update a fifth as often, but you're going to be updating by a lot more. So by using this conversion here, it allows you to run at the exact same speed on various different hardware. So that's a very common game development trick. Pretty much everybody does it to a certain degree. So that is why delta is passed into process, and one of those things to be aware of. Nothing specific to GDScript or Godot in general. Pretty much every single game engine takes the exact same approach. Now let's show you one other concept. So earlier we did set the position. And what that did is put it directly into a certain spot. It's a one and done kind of function. It's like sticking something on the board. Now what if we want to move by a certain amount? So instead of saying go to this spot, what I want you to do instead is say go left by 1 pixel, up by 1 pixel every frame, or something similar. Well, that's where translate comes in. Another function, translate, or transate if you spell wrong like I do. And translate gets a vector 2 passed into it. So basically we were telling it how far to move each frame. And what we're going to do in this case is we're going to move 100 pixels to the left per second. So once again, like that, and nothing in the Y. So by causing this little guy, what did I miss? Oh, I missed the bracket. All right. By calling this little guy right here, we should be able to run it. And now we are going to move to the left, and over every 1 second we'll have moved 100 pixels total because of our normalization. Now the only thing to be aware of, this little guy falls on its face if your frame updates are taking more than 1 second. But if your frame updates are taking more than 1 second, you've got bigger problems to worry about. And then finally, let's just add a little bit of logic in. We're going to use our positional information on our screen. So position dot x is less than 0. Position equals vector 2. Get same logic as before. Viewport size dot x, and so that will get our width. And then get viewport size.y div 2. So halfway up our height. So basically what I'm doing on this logic is basically once we get to the left-hand side of the screen, we are now going to jump all the way to the right-hand side and continue on. And that should be right. Hopefully there's no errors. Oh, there is an error. All right, let's try that again. So we move it at 100 pixels per second all the way across to the left, and then we get mostly off screen because the center, the offset is currently the center, so we're still seeing half. You'd probably want to do your connection to half minus the remaining width if you wanted to go all the way off screen. And then we kick back into the right and spin on back. So we actually showed you quite a bit here in our coding. We showed you how to directly locate something, how to get the viewport dimensions, how to scale something, how to rotate it once and done. And then we also went into the process function and showed you how to do it on a per frame basis. So basically translate to move something by a certain amount, and rotation instead of rotate to increment or increase the current rotation. And then we also looked at how to do normalization using the delta value passed into the process function. So that's quite a bit. Pretty successful. So let's move on from simple sprites. And now we're going to deal with something called a sprite atlas. Now a sprite atlas and a texture sheet and all those things are, it's really like this guy right here. So where did I call it? Night walk. See this guy? That is a texture sheet or a sprite atlas. The whole idea behind it is basically you can put a whole bunch of images together in a single texture file. The advantage to this is for OpenGL graphics or Direct 3D graphics, loading and binding texture maps is a somewhat expensive process. So if you've got a lot of similar or like-minded textures that are going to be used together, an often very common thing is the UI. You're going to use a lot of the components for the UI on screen at once. It makes a lot of sense to load them all together into a single file, and you get a performance boost out of doing so. It makes sense from a logical perspective. So that's why people often create atlases or texture sheets, etc. So now we're going to show you how to go ahead and use one of those. So we start off pretty much the same process. We're going to create another sprite. We'll call it, sprite, like so. And this guy we will call my atlas sprite. And in this particular case, we had earlier on, we used a texture. So we dragged and dropped our single texture onto this guy and created it that way. What we're going to do in this case, however, is use an atlas texture. So new atlas texture. So once it is created, come on down here and click edit, like so. And then here, we can load it, like so. And now we have to tell it what region or space to use on this guy. So if I go on back to it, I don't have it open, but my texture is 2947. This makes absolutely no sense for most people, but it is 2947 by 1420. Now, I'm going to go on a bit of a tangent here, or a little off in space. One thing you will often see is power of two textures, and this is sort of becoming a bit of a legacy, but it used to be required that your texture sizes be powers of two. So 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, and on it goes. Now, there's a reason why I can come up with those numbers so damn fast, is because they are, or at least were, important. Now, a lot of times, some drivers will actually still work faster with power of two textures. So in those cases, it's often actually better to leave dead space to round up to, or to change the dimensions so that you match those. But for most graphics hardware, it's actually becoming less and less important. All right, so there you see, the TextureAtlas now knows how far or how much to actually span that we're working with. So now we can go ahead and create one of these in our scenes. Or where is it in the scene? All right, just a sec. This is going to confuse me with this guy. Oh, there we go. I don't know why it didn't update already. But there is our TextureAtlas. Now, obviously, that's not what we want. We actually only want to use an aspect of it or a region within it. And that can be done using region right here. So we could basically say only use, this many pixels, this many pixels. But in this case, we're actually going to say instead that this entire atlas is used for an animation. So that is under the animation section here. And we just tell it how many frames they are. So vertical frames, we have 2. And horizontal, I don't know why to this day, but I get vertical and horizontal mixed up constantly. I don't know why. So we got 2 vertical frames, and we have 5. There you go. Oops, still in rotate mode, eh? So we have 2 vertical frames, 5 horizontal frames, and let me just bring this guy down like so. All right, it was not happy with that movement. Give me 1 second. Okay, not entirely sure what went wrong there, so I've recreated my guy, as you can see here. So I'm just going to select my other sprite, and we'll hide him. So I think I just ran into a bug of sorts. I'm not 100% sure what's going to happen there. But as you can see, we're here on our guy. We can switch between frames. So if I go to 2, we update to that particular frame of animation. 3, we'll go back to 0, so the very first frame. And so it is one way you can provide animation. And let's actually show you a very quick, simple, hacky animation version on here. And then we'll show you the right way to do animation in a second. But so let's attach a script to this guy. All right. So in ready, what we're going to also demonstrate here is timers. Timers are pretty awesome. So let's go up here and let's create a timer, var timer. Now timer is just a node like any other. So if you come on up here, you can find it and all of its documentation right here. It is under the type of node. It's not visible, so it's not under spatial or node 2D, as you can see. So there we're gonna go declare our timer. Timer equals timer.new. Let's create a new timer. Timer.connect. We're connecting the timer to an event. That event is timeout. And then it calls itself when the timeout occurs. You could call another object in this case, and we're going to call the function tick when that timeout occurs. So basically, the timer is now waiting for the event timeout to happen, and when it does, call the function tick, which by the way, we'll create in a second. Add our timer to the node, to our scene. So, oops, no J. Timer.wait time equals 0.2 or 5 frames per second in that case, or 200 milliseconds, depends on how you want to look at it. And let's start our timer up. So of course we need a tick function. Tick is here. And pretty straightforward. What we're going to do is if self.frame equals 9. Frame again is that value we were playing with just a second ago. All right, here, frame, right there, that value, and we're just going to manipulate that using code. So if we're less than 9, self.frame equals self.frame plus 1. You'll notice there is no plus plus operator in GD script, which is kind of annoying. Self.frame equals 0. So we go 0 to 9 frames, or 0 to 8, and then we start back over at 0 when we are done that. We'll save that out. Run our code. And there is our night walking animation happening. So pretty straightforward, pretty simple. Again, that is instead of using one particular sprite though, we have a set of sprites all on a single image called a TextureAtlas that are feeding this. Now also you could again have used the TextureAtlas. You don't need to use it for animation like I did. You could have ignored that part. Instead said, I want a piece of it by specifying that rectangle down here. So that's how a TextureAtlas can be used. And now that we're done with that, let's hide this guy. And finally, we will show you how to actually do animation. So that's not how you would properly want to do animations in general. Instead, what you want to use is an animated sprite. So come on up here, animated sprite is the type of node. So instead of sprite, we're creating an animated sprite. And you'll notice it has an issue here. Sprite frames resource must be set. So basically, it's got some things that we need to define for it in order to be able to continue. Remember earlier on, we jumped in this folder called anim. It's got a set of animations, 10 frames of jumping, 10 frames of running. We head on back over here to our animated sprite. In the properties, we have this frames. We want to create a new sprite frames like so, and then edit them. And you'll notice a new editor popped up right down here. So let's make our first animation. You'll notice it's got a default. We will change that default to run. Grab all of our run frames of animation like so, and pop. So there is a running animation. And if you want your animation to loop, if you do, click yes, and then it will now loop. Here is the speed. So this is the same as setting that 0.2 like we did a second ago. So this is going to update at a speed of 5 frames per second across our animation. And yeah, that's kind of the extent of it, to be honest. Down here, we can set its animation there. So we now have the run animation. We can turn it to playing equals on, and you will see it automatically start going right there. Let's go back to our editing of the... We could change, we could speed it up there, etc. But what we're going to want to do is create another animation here, and we will call this jump. What did I call it? I'll be consistent with my jump attack. Like so. Once again, you're probably pretty predictable, frame by frame here. Now, as it stands, each one of these frames by the file name is the order that I want it. If they're not, what you'll often have to do is drag them over one by one so they're in the proper order. Nice thing is, since my file names actually match the order of my animation, it works out correctly for me. But if your frames names don't necessarily match up to the frame sequence, you may have to drag them one at a time. So you'll notice the number down below it is the nth order that it appears in the animation. So we now have our two animations. I don't remember if I looped this guy or not. I don't think it's going to matter because we're ultimately going to control this guy with code. So if we head on back over to our animation, you'll now notice we have a choice. We can do the jump attack, which is not... Oh, it is looping. I didn't think that was looping. Or our run animation, like so. And again, we could change the speed back in the animation editor. Now, you got a couple of other options down here. We're not going to really play with anything, but you'll notice the playing that we turned it on so that we can actually see it running. So it starts off animated. Centered is the exact same as Sprite. This guy doesn't inherit from Sprite, so it had to implement that itself. You've also got the ability to change the offset. So if you want to make it bottom left or bottom right corner or whatever, you would do that here. And you can also flip the direction horizontally and vertically, if you wish. And this is useful for doing sprite flips. So if your left animation walk and your right animation walk are the same, you can get away with it just basically by having one walk animation and then flipping it in the appropriate direction. So otherwise, it is exactly like a sprite. We have a number of animations attached to it. Let's go ahead and create a script. All right, create. And what we are going to do is use a animation finished call. Now, I want to show you something here. You can also do this way. So if you go to the node, the signals for it, you can connect them that way. So I could pick this guy and then wire it up appropriately. These are all the various different event signals that this particular node will handle. But in this case, again, we're going to handle it with code. Head on back over here. So, and all we're going to do is, first off, in our ready function, say connect animation finished. So you can get code completion for it. You could connect it to another object. We're connecting it to our own script here. And on animated sprite animation finished. Wow. I think that was code generated the first time I did this example because that is long-winded. All right, and now we need to implement that function like so, and pretty simple. So all we're going to do is if self.animation, so if the current name of our animation is run, so the current animation that just finished, his name was run. In that case, we want to switch our animation up. Switching animations is just a matter of that. That's all that was involved. And we'll do this one with an else. Like so. Save that out. Let's go back to our editor. Move this guy on screen. Eek. On screen-ish. And run him. And nothing happens. Okay, I screwed something up. Animated sprite, inspector, run animation, playing. Okay, I must have fat fingered this guy. I turned looping off for some reason on my run animation. That's not what I wanted. So anyways, now we run it. And boom, there's our one animation playing. Now we're in our run cycle. Run cycle ends. We do our jump attack and running and jump attack, etc. So obviously you could have 20, 30, 40 different animations. Your jump attack, you probably obviously want to increment the position, etc. But essentially, you just saw how easy it is to work with an animated sprite set. So the biggest thing between this one and the Atlas is that we used a whole bunch of individual frames that we coordinated into sprite frames. Now, you might be asking yourself, hey, can I use a TextureAtlas in place of a bunch of individual files? And the answer is no. And why? I don't know. This is one of those areas where Godot is actually quite a bit different than pretty much all the other game engines on the market. I don't know why you can't feed this using a TextureAtlas, but unfortunately, you cannot. Now, stay tuned later on, and you'll find out that there is animation player built into the Godot engine that allows you to animate just about anything with even a lot more power than this. So we are going to get to further animation details a little bit down the road, and you're going to be pretty amazed with what actual Godot is capable from an animation perspective. But as you can see, what we did today was actually quite simple. And another topic is spinal animation. Basically, you can do bone-based animation in Godot, but again, we're coming up on the 40-minute mark, way beyond what I want to go in today. Like I said, we covered quite a bit today. And a quick summary of what we covered today: we looked at the 2D editor, we looked at bringing in sprites, how to manipulate sprites, how to translate, rotate, all that. We looked at normalization over time with the process function. We looked then at creating a TextureAtlas, having a simple animation using a timer, and then finally looked at the animated sprites, defined multiple animations, switched between them. Quite a bit to cover actually in one topic, and hopefully you can start seeing some of the power of the Godot engine in this tutorial. I know this one was probably a bit more exciting than, nodes and, introduction and all that. So this is when we're starting to get into the meat of how to actually work with the Godot engine. And if you're looking at creating a 2D game, you probably are sitting on about half of what you need to know already just from this one. So like sprites, animated sprites, and atlases are kind of the key concept behind 2D. So hopefully you did find this particular tutorial useful. Again, if you did, please of course click a like, and if you're into this series, do hit that subscribe and sadly that notification button to get updates when I update them. Should, as I said, have the GD script one up very, very shortly. And one last plug, if you do enjoy the game from scratch Godot video, hopefully you would also enjoy Godot the book, which is about the same pace. It's generally about 1 or 2 chapters ahead of what I am at the video series, but that is available in a work in progress form to all patron backers and will hopefully be up for pre-sale soon, and I will put a link down below when it is. Really help the channel out with that one. All right, that's it for now. I will see you all later. Goodbye.